Whereas you need to have your own statistical table. Okay, maybe but if you don't have, we will provide the partial like what I give to you during the quizzes lah. Okay. What else? Okay, so next week, it will be no class on Thursday. Okay. Because you have to prepare. Okay, the test will be at night. Okay, so there will be no class on Thursday. On Tuesday, I will inform later whether there is a class or not. But basically, if there is a class, I just want to discuss about the task. So maybe you can ask me, maybe you can discuss what do you don't understand, or maybe you can try the test from past semester. Then we can discuss that. Maybe I will pick one set, okay, from test from previous semester. Then we can discuss on that class on Tuesday. Okay, so there is no class on Thursday. Okay, but on Tuesday I will inform later. I will confirm later whether we have class or not. Okay, so basically the subtopic for next week we will discuss on next 2 weeks. So maybe on next 2 weeks we will have class on Tuesday and also Thursday, okay, to cover the subtopic for next week and the next 2 weeks. Okay, that's it for the task. Okay, anything you can ask me later. Okay, so we go to the subtopic for this week. Okay, the exercise that I asked you to do. Okay, we start with the 2.5 confidence interval for the difference between two population proportions. So the idea of the proportion we have discussed last week. Okay, so it is about percentage of something, probability of something. Okay, that something is your success characteristic. Okay, so basically the proportion, it is for qualitative data. Okay, when you have quantitative data, it will be either mean or variance. Okay, but when we have qualitative, the most what we call suitable parameter to use is a proportion. Okay, so estimate the confidence interval for the difference between two population proportion. So similar as a single proportion, we have single formula. So basically from proportion onward, it will be what we call quite easy because of we have single formula only, not like when we discuss population mean. So population mean, we have a few formulas that we need to consider. So the crucial part on formula, okay, which formula that we need to use. Okay, salah pakai formula, memang everything will be zero. Okay, okay. So so we have pi1 minus pi2. So which one minus which one? Similar as what we did for the mu1 minus mu2. Okay, depends on the question. Okay, which one minus which one, or you can decide by your own if you have general question. Okay, so the estimator for the pi, we have p1 and p2 here. Okay, so the whole thing here, that's your estimation error. Okay, we use the Z distribution as our distribution, and the whole thing here, this is your standard deviation for the pi1 minus pi2. Okay, so similar as a single proportion, it is between 0 to the 1. But because of we calculate for the different here, okay, and sometimes the value here greater than the value here, then sometimes you will get negative for the confidence interval. So it is okay to have negative because we calculate for the different. Okay. Okay. So the idea of the confidence interval similar as a single proportion. Okay. So because of it is between 0 to the 1. Okay. The idea for the proportion, it is between 0 to the 1. Then when you calculate for the lower bound, automatically upper bound equal to 1. Okay, so when we calculate for the upper bound here, automatically lower bound equal to 0. So because of single formula, then it should be no problem with the formula. Okay, so what we modify, only the alpha here, no need to divide by 2. The rest will be similar. Okay. So we go to the exercise 2.5, number 2. Okay, the one that I asked you to do. Okay, I believe that you already read that and you already do that. What is the variable? Variable of this question?
Strength of wire.
Strength of wire. What is the data that being collected here? What kind of data that being collected here? Strength of wire, it is what we call, it is not the data that being collected. We didn't collect the data of strength of the wire. Okay, we collect something else here. What is the data? What is the variable? Data is your variable.
Test. Test
Test.
column.
Kita bincang nombor 2, bukan nombor 1.
Specification.
Type of wire.
What?
Test column.
Siapa yang jawab test column tu? Kita discuss nombor 2 lah. Again, what is the variable?
Type of wire.
Meet the specification.
The wire that met the spec. Okay, so the type of wire here, yes, you have two type. So two type of wire, two different type of wire means that you have two different population. Okay, so we have the gold and also aluminium. So we have gold and also aluminium. Okay, so the variable is the wire that met spec. Okay, because in this what we call within the sample that have been drawn, we identify the unit that met the spec. So your variable unit that met spec. Other than that, what we can write as your variable? Other than we said unit that met spec, what we can write? Other than this.
That not met spec.
That not met the spec, also correct lah. Okay, that not met the spec because the data is now, okay, so we have unit, so it will be like unit 1. The question or okay, what we need met the spec or not. So it will be like unit 1, yes, unit 2, no, unit 3, yes, unit 3, unit 4, no. So other than you write unit that met spec, so also correct if you write unit that not met the spec. Because you also collect that lah. Okay. Okay, in a sample of the 85, what is 85?
N1.
N1.
Okay, with the gold wire, 68 unit met the spec. So 68.
X1.
And
Why
N1.
in sample?
X1.
Why in a sample of the 120, 120? It is?
N2.
N2.
And 2. Okay, 105 unit max spec. So 105.
X2.
X2.
So we have the first one is information of the goal. So we have N here, we have the X. 85, 68, 120, 105. Okay, this is what we have. Find the 98% confidence interval for the difference between population proportion. So it is clear that we need to calculate population proportion. Okay. So there is no doubt about that lah. Okay. Of the circuit made with aluminium and gold wire. So with aluminium and gold wire, automatically aluminium is a first population and gold wire is a second population. So it means that we have to do aluminium minus the gold. Okay, because already specific here, we need aluminium first and then gold. Okay, if you have a general question, for example, of the circuit made by both wire. So it's up to you. You can do aluminium minus gold, or you can do the gold minus aluminium. It's up to you. Okay, but in this case, we already specific the aluminium and gold, so it has to be aluminium minus gold. If you do gold minus aluminium, also it will be accepted, but it will be penalty at the end. Okay, your mark will be 1 mark will be deduct for the whole. Okay. Okay, so what we need here, 98% pi aluminium minus pi gold. Okay. That not met the spot. What does it mean? That not met the spot. Apa yang kita nak di sini? That not met the spot.
That's one.
That's one. So here, okay, so the what we call the given information is a met the spot. So the success characteristic is a met the spot. Okay, but the question we need to construct confidence interval for those who not met the spot. So what does it mean? What we need here?
Total minus success.
Failure characteristic. Okay, so means that we need to construct the confidence interval for the failure characteristic. You are given success characteristic, but we need you to construct failure characteristic. Okay, so you can write your formula, you can modify your formula. Okay, what we need. Oops, sorry. Okay, so what we need here is a Q. So QA minus QG okay, QA minus QG plus minus Z alpha over 2 and G. Okay, so that we aware lah. Okay, so we need to construct the confidence interval of the failure characteristic. Okay, so how to find the P? Okay, how to find the Q? Q is equal to
Number not success per n.
not success per n, or it is 1 minus P. Okay, so you can calculate the P first and then 1 minus P is your Q, or number of not success, number of failure divided by n. Okay, so or you can do 85 minus 68 divided by 85. Okay, and this one 120 minus 105 divided by 120. Then you can get the Q. Okay, so you can find the Z in your statistical table. What is confidence interval? Lower bound.
Upper bound.
More is negative.
0.0.
Negative
One.
0.048.
Negative 0.0480 and upper bound
0.198.
0.1980. Neolink, you can check your calculation. I think, okay. Generally, you can check your calculation. Okay. But based on your answer just now, I think you do gold minus aluminium. I think. Okay, so recheck your answer. Okay. So then it's okay to have negative confidence interval, but when we have negative confidence interval, the interpretation will be different lah. Okay, because we need to make sure that negative confidence interval is significant to use. Okay, so okay, we have to comment here. We are 98% confident that the difference between population proportion between alum okay, just copy everything, not much, but is between, okay, convert into percentage, 4.8% mobile gold and 19.80% mobile aluminium compared to each other respectively. Question so far? If you have positive confidence interval, then you can interpret as usual.
Medium.
Okay. So we proceed to the next one. Okay, so 2.6, we have confidence interval for population variance and population standard deviation. So estimate the confidence interval for a population variance and standard deviation. Okay. So similar to the proportion, we have single formula for this confidence interval. Okay. So sigma square and sigma, if you need sigma, then you just find the square root of your sigma square here. Okay. So for the single variance here, we use chi-square as our distribution. Okay. So the notation chi-square like x here, okay, and then square. Okay, we have the probability value and then we have the nu. Okay, so nu here still n minus 1. Okay, so this is notation for the chi-square. Okay, it is not you find the value n square lah. Okay, because I seen some before this. Okay, the student tends to square the value. It is not square the value. Chi-square means that notation for the chi-square distribution. Okay. So the chi-square distribution, one thing that you have to know, it is a positive distribution. That's why if you can see the figure here, actually it starts from 0. Okay, that's why for the lower bound and upper bound confidence interval, we have different critical value. So basically we need to find two critical value for this case. Okay, so here we have alpha over 2 and here 1 minus alpha over 2. Okay, because this side and this side, they are different because of it start from 0. Okay, so it is different than when we have Z and T. Okay, when we have Z and T, lower bound and upper bound, we have similar critical value because Z and T, they are symmetric distribution. Okay, symmetric distribution means that it is 0 here. So here is a negative side and here is a positive side. Okay, so you will have negative Z alpha over 2 here and here positive Z alpha over 2. Okay, similar critical value, the difference is on the sign, negative and positive. Okay, so this one, okay, this understanding, it will be bring to the chapter 3 letter. Okay, you need to understand that Z and T positive, symmetric distribution, and chi-square and also F letter, it is positive distribution. Okay, so that's why when we go to the chapter 3 letter, when you have left tail and right tail, okay, especially for the chi-square distribution and also F distribution, whenever you have left tail, you still have positive critical value. Okay, but for the Z and T, when you have left tail, it will be negative critical value. That one is important. Okay, you have to understand why we have negative, why we have positive here. Okay. Okay, the one-sided confidence interval. Okay, we discussed in chapter 1 before this, the variability, it cannot be negative value. So that's why your sigma or sigma square, it is from 0 to the infinity. Okay, it cannot be negative value. So that's why it starts from 0 until infinity. Okay, if your variability is 0, means that there's no variation in your data lah. So means that if you have data set, your data close together lah. Okay. So should be no problem with the formula. You just modify the alpha, no need to divide by 2. Okay, so when we calculate for the one-sided lower bound, the A here automatically upper bound equal to infinity. We follow this idea lah. Okay, and then when we calculate for the upper bound here, automatically lower bound equal to 0. So we follow this idea. Okay. So we go to this question. Okay, the number 2 here. Okay, let's modify this question. Find the one-sided upper bound. Tak nak lah, lower bound. Of 95% confidence interval for the population variance of dissolution rate. Interpret your answer. First, what is the variable? Variable dia? What is the variable of this question?
Dissolution rate.
Dissolution rate. Okay. So we have 10 independent measurement of the dissolution rate of a certain chemical. Okay, so just 10 data, it is not all, it is not the data of all. So this is a sample data. Okay, so we need one-sided lower bound of 95%. Okay, confidence interval for the population variance of dissolution rate. Okay, so we need the lower bound. So n minus 1 s square okay, so the critical value is alpha only, and then okay, and then upper bound automatically
That's 1 minus alpha.
again the upper bound of this. So now we need to calculate what? Lower bound of confidence interval, the one-sided. So we just calculate the A. So the upper bound automatically what?
Infinity.
Infinity. Okay, so infinity. Okay. So we need S square from the data, and then we need this this critical value. So what we have here is a 95%. Okay. So 95%, 0.05. The no equal to? The no equal to what? The degree of freedom of your chi-square equal to? The degree of freedom of your chi-square equal to?
21.660.
Okay. The degree of freedom of your critical value here equal to what?
16.919.
Okay, I didn't ask about the answer yet. Okay. I asked about the degree of freedom of the chi-square equal to what?
9.
9. 9. Okay, so find in your statistical table the value. Make sure everybody can find that value. So chi-square, it is on page 38 and also 39. Okay, in table 5. Okay, if you have your own statistical table, you can refer to it now. Okay, please make sure that you know how to find that value. So we need 0.05 and 9. So it is 16.9190.
9.
Okay, the S square.
1.4318.
1.4318.
18.
Already S square. That one is a S or S square?
S square.
square.
To substitute in your formula, so we have 9, 1.4318 divided by 169190 and then infinity. So we get
0. 0.7616.
Another person, another student, you get this value or not? Betul? You get this value? The rest of you, do you get this one? This value, the S square? I think it's different.
I got 1.59.
09. Yeah, it should be that. Okay, 1.5901. So check your answer just now, eh? Okay, it should be 1.5909. Okay. Okay, check your calculation. You might, maybe you misread, maybe you read the sigma. It is supposed to be the S, the value of S, because what we have here is a sample data. So maybe you misread. Okay, maybe you read the sigma. It is supposed to be the S. Okay. So you should get the lower bound equal to
0.8462.
0.8463, betul?
Betul, Puan.
Nanti infinity. Okay. And then how to interpret? Okay, so because we need to interpret. So in this case, okay, interpret your answer. Okay, in this case, you can do like this lah. So we are 95%. So because of what we have here, 0.8463 until infinity. So you can write here, okay, the 95% confident that the population variance of dissolution rate is greater than 0.8463. Also correct lah. Okay, or you can write like what we do before. It is between 0.8463 and infinity. But it is better if you write in this form lah. It's greater than, because we don't know what infinity equal to what number. Okay. Any question so far?
No.
No, madam.
Okay, so
Madam.
we proceed to the next one, the last subtopic for chapter 2. Okay, so we have confidence interval for the ratio of two population variances. Okay, why it is a ratio? Because we need to make sure that the confidence interval that we have, it is greater than 0. Okay, because probability, it cannot be negative value. Okay, so just a simple formula here. Okay, it's just S1 square divided by S2 square. So to determine which one should be the numerator, which one should be the denominator, similar as what we did when we calculate for the different. Okay, so which one mentioned first, it is numerator, which one mentioned later, that is a denominator. Okay, so the crucial part is your critical value. Okay, the crucial part is your critical value. Okay, so for the ratio here, we use the F distribution. So F distribution, it is a package of 3 value. Okay, so for the F distribution, we have the first value that we have is a probability value, the alpha. Okay, and then the second value that we have is a first degree of freedom. In this case, we have the no 2, and then second degree of freedom, we have the no 1. Okay, so these 3 value, it is a package of F lah. Okay, you can call it as a package. Okay, because it is not like we multiply each value lah. Okay, so what we have is a S1 square divided by S2 square multiply with F1 minus alpha over 2. We need no 2 and no 1. Lower bound, and upper bound is a S1 square divided by S2 square. F alpha over 2. No 1, no 2. Okay. Okay, so no 1, no 2 here, it is just N2 minus 1 for the no 2, and no 1 is a N1 minus 1. Okay, just a simple one. Okay, so but the problem is on the lower bound here, because to find this value, we use the statistical table, and we have limitation for the statistical table. Okay, so F distribution, it is on page 40 until the end. Okay, so F distribution, it is on table 7 from page 40 until the end. Okay, so what page that we need to refer, it is based on the probability value. Okay, so let's say that we need 0.001, then it is on page 40. Okay, so let's say that we have 95% confidence interval. Okay, so for the lower bound here, we need F divided by 2, 0.025. Okay, let's say that we have N2, 12, and then we have N1, 10. So no 2 equal to, no 2 equal to
11.
11. No 1 equal to
9.
9. So we need this one. Okay. For the lower bound here, 0.025, it is in statistical table. Okay. So the problem on your lower bound value. Okay. So lower bound, what we need is F1 minus 0.25, so 0.975, and then 11 and 9. So 0.975, it is not in our statistical table. Okay. If you have software, then it is another story lah. You can find using the software. But because here we are depends on the statistical table. So 0.975, it is not in our statistical table, then we have to improvise. That's why we use the formula. Okay. So we have what we need 1 minus alpha over 2, so it will be f alpha over 2, which is 0.025. We need nu 2 first, then here it will be nu 1 first, and then nu 2. Okay. After that, you can find your statistical table. Okay. If you go to the page in your statistical table, page 7, okay, you can go to the page 7. We have the formula for the confidence interval, and then after that you have this. Okay, what we have here is a general formula. In your table, general formula. When we discuss later the hypothesis testing, we are using similar formula this one. So general, what we call general formula. So we improvise based on what we need. So what we need is a alpha divided by 2. Then you just improvise here. Alpha divided by 2, no 2, no 1, and here will be divided by 2. Okay, improvise from the general formula. Okay, so make here. Okay, let's try to find the value. Just want to make sure that you know how to find the value of the f. Okay, the first one, this one, and then the second one, this one. Okay, so we need alpha 0.025. It is in page. What page?
44.
Okay, 44, and then we need 11.9. So we have
2.587.
11.9, 3.79.
58.
3.5879.
79.
Salah dah tu. Okay. So now when we read the F distribution from the table, okay, we didn't follow what how to say, we didn't follow this notation. Okay, it is not like the first one nu 2 we read from the nu 2. The second one nu 1 we read from the nu 1. No. Okay. So actually the nu 1 nu 2 in your table and in your formula they are different. Okay. Whenever come first in your distribution here, okay, here, whenever come first, we read as a first degree of freedom in table. So first degree of freedom in table, it is your new one. So the first here, we read at new one because the first here is a first degree of freedom, and then the second here, the second degree of freedom. So we read from new 2. Okay, so again, read again your table. We need what? 11.9 you should get.
3.9121.
3.9121.
121.
3.9121. Okay. Another one we need 911. It is
3.589.
3.5879. Okay. Sometimes student mistakenly read the table lah. Okay, the crucial part of the ratio is on the critical value. Okay, so that's why like this example. So the one-sided, the idea is similar as a single variance because ratio cannot be negative value, so it starts from 0 to the infinity. Okay. So, like I said just now, the crucial part on your critical value. But in this question, the number 2 question here, we are lucky because the n similar to each other. Okay, when we have similar n, so it should be no problem with your critical value because we have similar number for the nu. So nu 2, nu 1, nu 2 equal to 7 in this case. So both similar. So doesn't matter how you read your table, it should be correct lah. Okay. So construct a 96% confident interval for the ratio of two population variances. So it is clear here you have to find the ratio of two population variances. Okay. And for the ratio for this term, so far there is no other terms that we can use to replace this term. So it will be crystal clear that you need to find the ratio of two population variances. Okay, so please read your question carefully. Okay, it will be quite frustrated. Okay, from my experience previously, it is clear that you have to construct the confidence interval for the ratio of two population variance, but the student go to the population mean. Okay, so please read your question carefully. It is not everything you have to use formula for the mean. Okay, so it is clear that ratio of two population variance for all roving cohesion produced by control and heated strength. Okay, what is the variable? What is the variable?
Level of strength.
Level of strength. It is control and heated. That is your population. First population means control and heated here. Your population means that the data come from the strength. Okay, the data come from different level of strength. So the data come from control, the data come from the heated. But what are these data? So that's your variable. So what is the variable?
Type.
It is
Roving cohesion.
roving cohesion. That's your variable. Roving cohesion. So produced by the control and heated. So control and heated means that, okay, confident interval that we need to find it is as control
Yes, heated.
squared divided by as heated. Okay, so follow the question. And then 1 divided by F. So we have confidence levels 96, so 0 0.2.
02.
So we get confidence interval
0.1274.
0.04.
1274.
The upper bound
Three point seven six four four.
3.
3.7644.
3.7644. Should we put unit? There's a unit or not in this question?
Kilonewton meter per kilogram.
Okay, so we have unit in this question. This is your unit. In this confidence interval, should we put unit?
Yes.
Yes. Betul? Is it correct?
Don't
Really?
need,
We have to put the unit?
don't need.
Why no need? The opposite answer to the yes is a no. Okay. Why no? Why no need?
It's variance.
But the variance. What about variance? Properties that we discussed in chapter 1, variance is a dimensionless. Okay, so there is no unit represent variance. So even though you have unit in your question, okay, we cannot put unit, okay, because variance. Okay, and then how to interpret similar as what we did before lah, because we have positive confidence interval. Okay, any questions so far?
No.
Okay, so with that we finish the chapter 2. Okay, okay, you should start, okay, preparing for your test lah. Okay, anything you can text me. Okay, if you don't understand anything, if you want to ask about any question, you can text me later. Okay, so we proceed to the chapter 3. Okay, so chapter 3, we have hypothesis testing. So hypothesis testing is one of another method for the inferential statistic. Okay, so again, what we discussed in this course for the hypothesis testing, they are for the normal data. Okay, normal data set. Okay, if you have non-normal data set, what we can do, we can convert into normal. It will be some formula that we can use to normalize your data, or you can use the method for the non-normal data. Okay, so method for the non-normal data, in general, we call them as a non-parametric method. Okay, so just for your information, so that you know lah. Okay, the one that we discussed in this course, it is for the normal data set. Okay, so that's why in your assignment part 2, you have to test for the normal. Okay, first. Okay, but if your data is not normal, you just proceed to what we have here lah. Okay, we just assume that it is normal data. Okay, so the reason why we discuss, or the reason why we do the hypothesis testing, okay, just now in chapter 2, confidence interval, in general, why we construct confidence interval is to estimate the population value. Okay, so we have 3 different parameters that we discussed. Okay, we have mean, we have proportion, and also we have the variance. Okay, from the variance, you can get the standard deviation. Okay, so similar to here, similar to the chapter 3, we will discuss these 3 common parameters. Okay, you have the mean, you have the proportion, and also the variance. Okay, so if you have quantitative data, okay, the most suitable parameter to use is a mean or variance. Okay, so it depends on the situation in your question, whether we need to test for the variability or whether we need to go to the mean. Okay, But when you have qualitative data, okay, the most suitable parameter to use is a proportion. Okay, so it should be clear. Okay, based on the variable, you have the quantitative data or qualitative data. Okay, if you have qualitative data, then straight to the proportion. Okay, so the reason why we discuss this hypothesis, okay, or why we form this hypothesis, because at the end we need to make or we need to draw a conclusion about the population. Okay, so because when we have something, let's say that we need to test something, it will be impossible to test to all the subject that we have. So what we do, we draw a sample and then we test. Okay, we test and then we apply the test statistic, we make our decision. At the end, the conclusion that we make, it is represent the whole population. Okay, so your sample must be come from that population. Okay, so in general, hypothesis testing is used to draw a conclusion about the characteristic in population. Okay, for example that, let's say that you have a new method for the production. Okay, so we have a new method for the production. Okay, so what we collect the item, okay, we go, let's say that we use the proportion, okay, the item that met spec or not met the spec. So we have a new method that we want to test, the effectiveness of that method. So how do we test? Okay, it is impossible to collect the data from the item produced, for example. Okay, so what we do, we just draw a few, not a few sample, a sample, okay, maybe 100 item, okay, from all the item, and then we check whether the item produced met the spec or not. Okay, so by using the new method and then by using the old method. Okay, so we can have here, let's say that the variable, the data that we collect item met spec. Okay, so we have method, we have the old method and then we have the new method. What we can test here in terms of item met spec. Okay, so the new method supposed to be what? Based on this variable. In your opinion, the item produced by the new method supposed to be what? Betul ke soalan saya tu? Okay, we need to test the effectiveness of the new method. Okay, so the item that we produce by using the new method should be what? Anyone?
Accept or not?
It should be better than the item produced by the old method. Okay, so the variable that we collect is an item that met spec. So in this case, the old method here should be less than the new method lah. Okay, if we can write this mathematical writing here. Okay, so the new method, because of we develop the new method, so we expect that the new method is better than the old method. Okay, so again, it is impossible to check all the item produced. So what we do, we draw a sample, maybe 100 sample, maybe 200 sample, depends on a few factors that we discussed in chapter 1. Okay, it is depends on the cost, depends on the time that we have. Okay, and then based on the sample data that we have here, we calculate the test statistic and then we find the critical value and then we make our decision based on that. Okay, at the end, the conclusion that you write, the conclusion that you draw based on the decision that we made, okay, it is about the population. It is represent population. So we believe that by using sample data, for example, new method better than old method. So you as a as a manager, then you can decide after that whether want to invest on the new method or not. Okay, so let's say that it is confirmed based on the sample data we have, it is confirmed that the new method better than the old method. So we can invest on new method, for example. Okay, let's say that after we do the hypothesis here, the testing here, the old method better than new method. Okay, then you as a manager, you can stop the production, or you can stop invest on the new method, or maybe you can create another method, for example. Okay, that's the purpose of the hypothesis testing. Okay, I think it is important for you to understand why we need to do this. Okay, so hypothesis testing in general is to conclude or draw a conclusion about the population. Okay. How many methods that we have for the hypothesis testing? If you already go through the videos and note, you should know that lah. Okay, how many methods that we have?
3.
3 methods. What are them?
Traditional.
Okay, traditional method, and then second one,
Confidence interval.
interval method. The third one,
P-value.
p-value method. So all together we have 3 methods that you can use. Okay, so this is the expected outcome. Okay. Okay, so we go to this. So for the content, we have about 10 subtopic. Okay, so 3.1 just to discuss the terms and definition that we have for the hypothesis testing. What is statistical hypothesis? What is the type of statistical hypothesis? What is acceptance region? What is rejection region? Critical value, test statistic, what else? Significant level. Okay, how to make your decision. Okay. So, and then we have the procedure in hypothesis testing. Doesn't matter what method that you use traditional, or you use the confidence interval, or you use the p-value, you will have about 4 to 5 steps, okay, for the hypothesis testing. Okay, and then we start with the population mean. So 3.2 until 3.7 here, we will discuss the traditional approach. Okay, and then we have the confidence interval approach. Okay, that's why I always say that chapter 2 and 3, they are related to each other. So confidence interval approach here means that the whole chapter 2 that we discussed just now. Okay, the whole chapter 2. So they are related to each other. And then we have p-value approach. So we don't calculate manually for the p-value approach. If you need to use the p-value approach, we will provide you with the output from Microsoft Excel. Okay, so your assignment part 2, it is about p-value approach. So you have to use the Microsoft Excel and then obtain the value of the p-value and then form your hypothesis testing. Okay, so your assignment, it is about population mean and also 2 population mean. After we discuss 3.2 and 3.3, you can go to the YouTube and find the video of the hypothesis testing by using Microsoft Excel. Okay, this 3.9. Okay, then you can start with your assignment. Okay, do not wait until we finish the chapter 3 and then you start with your assignment. Okay, because you have about 1 week after that. So if you start early, then you can submit early, nah? Okay. But still, the due date after a week, we finish the chapter 3. So refer to your teaching plan. Okay. So the end of this chapter, we will discuss the errors occur. Okay. So when we discuss confidence interval, we do have the estimation error. When we discuss sampling in chapter 1, we have the sampling error. Okay. So in chapter 4, we discuss the hypothesis testing. We will have type 1 and type 2 errors. So these errors occur in hypothesis testing. Okay. Okay, so we go just a quick review on the 3.1 introduction to the hypothesis testing. So statistical hypothesis statement concern about parameter or parameters of one or more population proportion. So the conclusion that we made, it is about population. Okay, so that's why the hypothesis here must be statement about the population. So that's why notation that we need to use is a parameter. So it will be either mu, it will be either pi or sigma square. I don't want to see a statistic symbol. Okay, statistic symbol means that S bar, P as S square. No. Okay, hypothesis, the statistical hypothesis must be parameter. Okay, notation that we use is a parameter. Okay. Okay, so we have two type of statistical hypothesis. We have the null hypothesis and then we have the alternative hypothesis. Okay, so the rule is H null and H1, they cannot be overlapped to each other when we formulate the hypothesis. Okay, so if we have the line number here, for example, just a simple example. Let's say that we decide that H null cover from 3 and below. That's your null hypothesis. So automatically H1 must be covered from 3 and above. They cannot be overlapped in any point. So you have to state in your mind, when you formulate the hypothesis, you have to check the sign that you use. Okay, sign means that greater or less, something like that. Okay, so you have to check the sign that you write, just the sign that you write, they must not be overlapped to each other at any point. Okay, because H0 is a statement that do not cover by H1. H1 is a statement that do not cover by H0. So they cannot be overlapped to each other. Okay. So when we go to the question, your question will give you either one, whether H0 or whether H1. How do we identify the one given by the question H0 or H1? It is based on the sign. Okay, because H0 is a statement with the equal sign. You will have either not, sorry. It will be either equal, less and equal, greater and equal. Okay, whenever you have the equal sign here, then that statement is H0. Okay, so H1 opposite to that, H1 is a statement with not equal sign. Okay, you will have either not equal, less than, or greater than. Okay, so that's how we differentiate. In that question, okay, it gives us H0 or H1. It is based on the sign here. Okay, H0, it is statement with always with the equal sign. H1 statement with not equal sign. Okay, you can interrupt me anytime if you need to ask any question. Okay, so H0. So your question will give you either one. So when we have either one, you should be able to write the other one. Okay. So let's say that we get H1 from the question, then you should be able to write the H0 because they are not overlapped to each other. They must be opposite to each other. Okay. And then the type of task. Okay. So basically we have two type of tasks. The first one to tail and the second one to tail. Okay. In traditional method, it is important to know whether we have two tail or one tail. Similar to the p-value approach, because different type of task, it will be different value for the p-value. Okay. When you have two tail, you will have another p-value, and when you have one tail, we will have different p-value. So it is important to know the type of task. Okay. So one tail, it will be either right tail or left tail. So how do we know? For me, I will identify from H1. Okay. Whenever you have not equal here, two tail. Greater than right tail, less than left tail. But it's up to you how you're going to memorize this one. Okay, but for me, I will look at the H1. Okay, so it will be what we call, so the type of test here influence the critical value. Okay, because when you have two tail here, it will be, in general, it will be like this. So it will be two-sided. So automatically alpha divided by 2. So similar to the confidence interval. The idea is similar to the confidence interval. We have two-sided. Okay. And then when you have one tail, okay, for the right tail here, we will have this side only. So then it just alpha. No need to divide by 2. So similar to the left tail. Okay, left tail, we will have this side. Okay, so the shaded region of each type here, that's your rejection region. Okay, unshaded region, that's your acceptance region. Okay, so the location of the acceptance and rejection will influence your decision making method. Okay, any questions so far? No?
No,
Okay.
madam.
So when we formulate the hypothesis, okay, the left hand side here must be the parameter. Okay, so parameter, it could be, it depends on the question whether you have mu, like I said just now, pi, sigma, and sigma square. Okay, the right hand side here, it is a value. Okay, the theta note here represent value. It is population value, not the sample value, population value. Okay, especially for the single population, this value will be given in your question. You just need to find it. Okay, if there is no value given, we just assume it is 0. Okay, especially when we dealing with the two population. Okay, two population mean or two population proportion or variance. Okay, if there is no value given, it is 0. We assume 0. Okay, but for the single population, it will be given somewhere in your question. So theta note here, it is value, population, value. So hypothesized value here is another term for the population. So it will be either population value or true value similar. Okay, represent population value. Okay. Okay, so this is a common phrase that we use for this hypothesis. Okay, so you should be well known with the terms that we use here. Okay. Yeah, we discuss here when we discuss the exercise. Okay, so we go to the 3.2 here. So hypothesis testing for the population mean. Okay, population means that the parameter that we use when we have the quantitative data. Okay, so test a population mean when population variance is known or unknown. So basically the formula, the idea of the formula is similar as what we have for the chapter 2, but the difference is we calculate for the task. Okay, we calculate for the task. So how to choose which formula that we need to use? Okay, similar as a confidence interval, we need to know the first condition, sigma is known or unknown. Okay, if unknown, then your n greater than 30 or less than 30. So now we have the z and also we have the t task. Okay, so when we have the z task, automatically we compare with the z distribution. When we have t, it will be compared with the t distribution. Okay, we cannot compare Z with the T, we cannot compare T with the Z. They are different distribution. Okay. Okay. So for the hypothesis here, we have three type here, to tail, right tail, and left tail. Okay. So because of population mean, then parameter will be mu, not the S bar. Okay, so we have the mu naught, the population mean. Okay, the value of the population mean. Okay, similar. Okay, so we go to the exercise. Okay, I ask you to do the number 5. Okay, so number 5 here, quite interesting question, and I think that you really need to understand the number 5 here. Okay, if you understand this one, then the rest should be okay. Okay. First, what is the variable? A rocket meets its target by an average of 0.88 km with a standard deviation of 0.04 km. Okay. A new design rocket is supposed to increase accuracy. A random sample of the 30 locations were occupied with this new rocket to test it. The 30 rocket meets by distance with a mean. Does the new design rocket able to increase the accuracy? Okay. From here until here, what we call the purpose of this question or the purpose of this experiment is to test whether the new design rocket able to increase the accuracy or not. So the purpose of this experiment, it is your hypothesis. So we formulate the statistical hypothesis from the purpose of this experiment. Okay, so the last sentence here, okay, we get our statistical hypothesis. Okay, but before we jump to that, okay, as I mentioned, we have to extract the information first, similar as what we did for the chapter 2. Okay, extract the information first. Okay. First, what is the variable in this question? Variable, anyone?
Target miss.
Target means. So target means, what kind of data that we collect there to discuss the target means?
Accuracy of target.
Accuracy of target, still, okay. Okay, accuracy of the target. How do we discuss that? What kind of data that we collect here to discuss the accuracy of the target?
Miss by distance.
By distance. So what kind of data that we collect? Okay, it is correct to say what we call it, miss by distance. So it is actually distance to
Distance.
how do we know it is a miss by distance? What we collect here?
Distance to target.
Distance to the target. Okay, distance to the target. That's what we collect. So then we know, oh, this rocket missed its target. Because what we collect is a distance to the target. So we know lah, this rocket missed the target. Okay. Distance of rocket to target. Okay. So then what we have? A rocket missed its target by an average of 0.88 km with a standard deviation of 0.04 km. A new design rocket. Okay. What is 0.88 and 0.04 here?
Mu.
Mu. 0.04?
Sigma.
Sigma. Why you said mu and sigma? What how we say how do you know they are sigma? What reason you said that they are sigma? They are population value. So it is correct that 0.88 is a mu and 0.04 is a sigma. Why we said they are population value?
Dia tak mention sample ke.
Kita mention sample ke apa. Okay. Okay, but not accurate lah, but close to it. Okay. So one of the what we call the hint that we can use to distinguish population and sample value. Your friend said old record. Yes, it is the old record because what we test here is a new rocket. So the data or the value given here 0.88 and 0.04, it is from the former rocket. Okay, here we have new design rocket and here it should be the old rocket. So the old record. So the this value from the past one. So anything describe the past study, previous record, the old record, there are population value. Okay, similar as what we discussed, if you still remember confidence interval for the single proportion, we have the new treatment and standard treatment, similar. But here we have the new rocket, new design rocket with the old design rocket. So that's why these two value population. Okay, other than that, another hint that we can use, okay, these two value were mentioned before we have the sample here. So most of the time they are population value. Okay. So the new design rocket is supposed to increase accuracy, a random sample of the 30. So 30 is your
N.
N. These 30 rockets miss by distance with a mean of 0.76 and standard deviation of the 0.04. Okay, so 0.76 it is
X bar.
0.04
S.
S, because these two values were calculated from the 30 here. And we said just now 30 is our N. Okay, so does the new design rocket able to increase the accuracy at 0.1% significant level? What is 0.1% here?
Z. Z. Z.
Z.
0.1% significant level. What is this? Alpha.
Alpha.
0.1% convert into probability 0.01. If there is no alpha given, what is your alpha?
0.05.
0.05. So we use a standard alpha 0.05. Okay. Sekejap Okay. So all the information already extract, then we go to the solution. So first, how do we know it is hypothesis? How do we know that we need to perform the hypothesis testing? Okay. The question is, does the new design rocket able to increase the accuracy? So what we do here, we create another rocket and then we need to know, does the new design rocket able? So you need to answer that does. Okay. So one of the method that we can use is a hypothesis testing. We cannot use the confidence interval. It must be a task. Okay, it must be a task to answer this, to conclude this. Okay, that's why it is hypothesis testing. That's why we have to perform the hypothesis testing, because we need to answer this, we need to conclude this. Okay, because this is does the new design rocket, it is for the all new design rocket. Okay, so hypothesis testing, we start with the step 1, formulate the statistical hypothesis. Okay, formulate the statistical hypothesis. So H0 and H1. Okay, I said just now, hypothesis is the purpose of this experiment. Okay, we formulate the hypothesis from the purpose of this experiment. So the purpose is to know whether the new rocket able to increase the accuracy. So the keyword increase the accuracy. What comes to your mind when we have accuracy? So now, obviously, it is a quantitative variable, quantitative data. Okay. So it will be the most suitable parameter to use, mu and sigma. Okay. So in this exercise, I want you to think what we call. I want you really to understand why here it is a mu. Okay, so it is not because this exercise under this subtopic, then you go straight to the mu. Okay, so if exercise, then you are lucky lah. But if we talk about test, we talk about final, then you really need to understand. Okay, why here we have to use mu. Okay, because when we go to the final, when we go to the test, okay, a test still okay because test is until 3.2. So by hook by crook it will be mu. Okay, but the final letter it will be what we call, it will be many subtopic involved. So you have to identify what parameter that we need to use here for our hypothesis. The parameter, based on the parameter, we know which formula that we need to use, what test statistic that we need to calculate. Okay. So the keyword here, accuracy. In your opinion, when we discuss the accuracy, what is the most suitable measure that we need to use? When we discuss the accuracy, what is accuracy, by the way? What is accuracy?
How close it hit the target?
How close the measured value to the target. So in this case, how close the rocket to the target. Okay, what is the most suitable measure that we can use to discuss that accuracy? Okay, here we, it is?
Lower than 0.88.
Okay, that's the value. Okay, the measure that I meant here, this is where we have to use the theory from chapter 1. Okay, so chapter 1, it is a theory that we will use until we go to the chapter 6. Okay, in chapter 1, what measure that we discuss to discuss the accuracy? If you see, it is
Center of tendency.
really central of tendency. Mm-hmm. What
Variation.
measure? It is
Measure
what?
of variation.
Measure of variation. Okay. So in chapter 1, the measure that we discussed to discuss accuracy and also dispersion is a measure of variation. So measure of variation is a variability. So the parameter related to variability is a sigma or sigma square, isn't it? Betul?
Yes.
Okay. I repeat again. Okay. So the parameter that related to the variation is sigma or sigma square. Okay. To discuss sigma, first, okay, look at the information that we have. Okay, if we choose sigma as our parameter, of course we need the sigma node, the population variance or the population standard deviation. Okay, do we have the sigma here? Do we have the population value here? The population standard deviation? Do we have? Yes, okay. Okay, so we do have this value. In our test statistic, it is similar idea as a confidence interval. We need the estimator. Okay, the estimator for the sigma, what is that? What is estimator for the sigma? Sudah, minggu depan test. What is
S.
the
S.
S? S. Do we have S?
Yes.
Yes.
Yes, we have S. We have sigma, we have S. But the value of the sigma similar to the, is it give any explanation? The value of sigma equal to the S? Is that mean something? The value of sigma equal to S?
Yes.
What does it mean? We have sigma equal to S. What does it mean? Okay. Okay. So sigma equal to S. Do you think probability here give the effect to the accuracy? I repeat my question. Sigma equal to S. Do you think the probability here give effect to the accuracy that we discussed in this experiment?
No.
No. Okay, that means that sigma equal to S, there is no effect on the probability on the accuracy that we discuss here. Okay, so the distance of the rocket to the target does not influence by probability because sigma and S that we have here similar to each other. Okay, so the idea is similar as if you still remember in chapter 1 when we discussed the measure of variation. Okay, why we use measure of variation when we have mean, for example, when we have measure of central tendency. One of the reason when mean is equal to each other. We have two set of data, but mean 1 and mean 2 equal to each other. When we have similar value means that there is no effect on the central tendency. So that's why we move to the probability. But here, there is no effect of the probability. So there is no use for us to use probability to discuss the accuracy. So then the most suitable one is a mu. Okay, because the mu that we have here and the S bar here, we have different values. So means that mean give effect to the accuracy. Okay, so the most suitable parameter is a mu. Any question? If sigma and S here, we have different value, then we can use sigma as our parameter. So, how to say? Both will be accepted, whether you use sigma or whether you use the S, the mu. But here, the most suitable one is a mu, because sigma or probability does not give any effect to the accuracy. Any question? That's the reason why it is a mu. Okay, do not what we call. You have to understand. Okay, why it is a mu. Okay, then you will understand how to identify what parameter that we need to use for our hypothesis. Okay, so it is mu. Okay, we do have the mu naught 0.88. Then we need to decide on sign. Okay, so we still on increase the accuracy. What kind of sign to represent increase the accuracy?
Greater than.
Greater than, really? It should be lower mean, because just now we have discussed accuracy is how close the measured value to the target. So means that how close the rocket to the target. So increase the accuracy means that rocket should be close to the target. So mean should be lower. Okay, so increase here should be less than. Okay, so this is one of the example. It is not necessary when we have increase, it will be greater than. You have to look at the variable, you have to look at the what we call the terms that we use. Okay, so variable is very important when we discuss hypothesis testing. It will influence your sign here in your statistical hypothesis. Okay, Hashna or H1? You, you get Hashna or H1?
H1.
H1. So what is your Hashna?
Mu
Greater and equal.
Greater and equal. Okay, must be opposite to the H1. Where is your claim?
H1.
H1. So claim determined by which hypothesis given in our question. So we get H1, then claim will be at H1. Okay, it is not compulsory to state the claim, but when you state the claim, it will be easy to write the conclusion letter. Okay, because in general, for the conclusion, we need to discuss what happened to the claim. Okay, whether you support the claim or whether you reject the claim. Okay, so step 2, the type statistic. So we already know it is a mu, single mu. Then we go to the 3 formula that we have discussed. Okay, so the first condition, sigma is known or unknown?
None.
It is
No,
known.
no.
None.
So sigma is known, then we go to the first formula. Z test x bar minus mu naught sigma divided by square root n. Okay. We have x bar mu naught 0.88, sigma 0.04, 30. Calculate the Z test. What do you get? negative 16.4317. So use for decimal, this is negative 4317. There is no unit for the test statistic. Okay. Okay. Step 3 is to find critical value. So critical value depends on first the test statistic and also the type of your statistical hypothesis. Okay. What is the type of statistical hypothesis here? It is the type of statistical hypothesis. Left tail ke, right tail ke, two tail ke? It is right tail, left tail, or two tail? Left
Left tail.
tail, because of we have less than here. So left tail. What happened to the alpha? Do we need to divide by 2?
No.
No.
No, because it is one tail. So left tail, you will have the lower bound here, okay? So Z test automatically the critical value must be Z distribution, okay? So as I mentioned before, Z test and T, they are symmetric distribution. So here 0, here positive side, and here negative side. So you will have negative Z alpha here. So 0.001. You will get find Z 0.001 in your statistical table, and then you just put the negative sign. So negative 30902. When we have left tail, it is compulsory to write the critical value in negative form. Okay. So when we have left tail, this is your rejection region. This is your acceptance region. Okay, acceptance and rejection we use when we do the step 4. So step 4 is to make decision, compare and decision. Okay, so to compare and decision, for the first start here, it is encouraged to draw this figure and then plot where is your Z test in this figure, whether fall in rejection region or whether fall in acceptance region. So your Z test less than critical value or greater than critical value?
Less.
Less than. So somewhere in rejection region. So what is your decision? Okay.
C.
When our test statistic is in rejection region, means that reject has none. When our test statistic is in acceptance region, then it is not accept. It is do not reject hash null. This is the answer that we write for decision. It is whether reject hash null or do not reject hash null. Okay, for the decision, we discuss what happened to the hash null. Reject or do not reject hash null. Do not write about hash 1. Okay, we write about hash null. Why? Because when we formulate the hypothesis, the rule is we assume hash null is true. Okay, when we formulate the hypothesis, the rule is we assume hash null is true. That's why in our decision here, we have to discuss what happened to the hash null. Whether we reject hash null or whether we do not reject the hash null. We cannot write the hash 1. You can write the hash 1 after you discuss what happened to hash null. Okay. So write the comparison here. So it is, so this is our Z, this is our Z test. Okay. So Z test less than negative Z 0.01. Okay, and then reject hash null. Okay, the benefit that you construct this figure, okay, sometimes, okay, especially when involve the negative value, okay, it could be mistake when you make when you compare the value, okay, when you compare the value here. So if you make a mistake here, we refer to the figure here, whether you plot correctly or not. Okay, but when you draw this figure, make sure to plot correctly, make sure to label where is your z-test, where is your critical value. Okay, so if you do a mistake here, I will refer to this figure. Okay, and then you can get some mark. Okay, and then step 5, conclusion. So the conclusion here, we discuss what happened to the claim. In general, we discuss what happened to the claim, not yet the hash null. Okay, we don't discuss what happened to the hash null in step 5. Okay, we discuss what happened to the claim. So here we reject hash null means that we say no to the hash null. We reject the hash null, we accept the hash 1. So because of claim at hash 1 means that, do you support the claim or not?
Support.
We support the claim because claim at hash 1 and we accept hash 1. So the conclusion here we can write at
Alpha to 0.0.
0.01. Okay. Alpha is compulsory to write in conclusion because if we change this alpha, critical value could be different, decision could be different. So the conclusion that we write about this population only valid for the alpha 0.01. Okay. There is enough evidence to support the claim that new rocket increase the accuracy. Okay. Or you can write at alpha 0.01 there is there is not enough evidence to reject. So similar meaning to what we write just now. To reject the claim that the new rocket increased the accuracy. Or you can just answer this question. Does the new rocket able to increase the accuracy? Okay, so you can just write at alpha 0.01, the new rocket able to increase the accuracy. Also correct. Okay, so I don't mind how you are going to write your conclusion as long as you support the right one. Okay, any question? So your test until this subtopic. Okay, for me, if you really understand this question 5, the rest should be okay. Okay, the rest is more simple than question 5. Any question? Okay. Okay, so again, there is no class on Thursday next week. Okay, I will inform later whether there is a class or not on Tuesday. Okay, so you can text me if anything, if you have any question regarding when you preparing for your test. Okay, I will reply as soon as possible. So thank you for today. If there is no question, thank you for today. See you next week, inshallah. Thank you, class.
Thank you,
Madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Okay.
Thank you, madam.